Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, the 2019 question on sequence and series. The closed line segment 01 is shown below. The first 3 steps in the construction of the Cantor set is also shown. Now note that you're not going to know what a Cantor set is. So step 1 removes the open middle third of the line segment 01, leaving 2 closed line segments, i.e. the endpoints of the segments remain in the Cantor set. Okay, so the Cantor set, you didn't have to know what it was, but it is the set of all numbers between 0 and 1, and they're all written with base 3, okay? And they're the endpoints as shown here. Step 2 then removes the middle of these 2 closed lines, and it leaves 4 closed lines. Step 3 then removes the middle of each of these to leave what's shown here in step 3. And of course, step 4 removes the middle of each of these, and so on and so forth. Okay, so the table said complete, or part A said complete the table below to show the length of the line segment removed at each step for the first 3 steps. Okay, so you can see here that it's told you that it has removed the middle third. Okay, so there's the third of that line gone. Okay, right. So then if we just concentrate on this one, how much is removed in each one? Well, you can either think of it as a third of a third here, and a third of a third is a ninth. And of course, one is removed here and one is removed here. So I've got 2 ninths. Yeah, that's probably the easiest way of doing it. The other way of doing it is to think that the way I look at it is the smallest denominator here is ninths. So a third is the same as 3 ninths. This is 6 ninths. So there's 1 ninth, 2 ninths, 3 ninths. So there's a ninth gone in the middle and a ninth gone in the middle. Okay, now down here, what's happening? Well, now we're working in 27ths. So he is 3 over 27, 27, 9 over 27, and so on and so forth. Okay, so you can see that there's a 27th removed out of each one here. Okay, which is 4 over 27. Okay, and then of course you can draw step 3 or step 4 if you wish, if that's where your strength is. I am useless at drawing patterns. I prefer to look at the numbers. So I'm looking here and I'm seeing from 1 to 2, I'm either adding 1 or I'm multiplying by 2. Yeah, that's about it. Okay, so then I look from 2 to 4. Well, I'm not adding 1 anymore because that would have been 3 on the top. So I am multiplying it by 2, okay, or doubling it. Okay, so the top is a doubling. Then let's have a look at the bottom. 3 to 9, I'm either again adding 6 or I am tripling it. Okay, so adding 6, the way I'm saying it would be in our arithmetic sequence, multiplying by 3 would make it a geometric. So the bottom is a multiplied by 3. Okay, so the top then becomes multiply 4 by 2 is 8, multiply 27 by 3 is 81. Step 5, 8 2s are 16, 81 by 3, 3 1s are 3, 8, 16, 24. Okay, so that's how I would end up working out my table. Of course, you can do it visually or patterns or whatever way your brain thinks. Okay, we are all wired differently, so we're going to see that differently. Okay, so that was a part 1, and I think that was worth 10 marks. So it's question 7, so it's going to be one of the longer questions on the 2019 paper. Part 2, find the total length of all of the line segments removed from the initial line segment of length 1 unit after a finite number n of steps in the process. Give your answer in terms of n, okay? So when we've worked out the pattern here, we've now established that it's a geometric sequence because I'm multiplying by a common ratio, and my common ratio is 2/3, okay? I'm multiplying the top line by 2 and the bottom line by 3. Okay, so if I go to my log tables, you can see that I have 3 formula for geometric. I have the TN formula, which gives me a formula to find a specific term, or I have 2 SN formulas. And the S formulas gives you the sum of a number of terms. So you have SN, which gives you a finite number of terms, and you have S to infinity, which gives you an infinite number of terms that you're summing up. So when we did this one, it says a finite number, okay? So it's this formula here. Sn is equal to A times 1 minus r to the power of n over 1 minus r. Let me just double check that. A times 1 minus r to the power of n over 1 minus r. Okay, so you need 2 pieces of information here. You need the first term in your sequence, and you need r being your common ratio. Okay, so in mine, my first term, because remember we are summing up how much is removed, I think. Find the total length removed, okay? So this is the table that tells us the lengths removed. So my first term is a third, okay? So A is a third. And my common difference is always Tn plus 1 over Tn. So you just take a term and you divide it by the term before it. So I could do 2/9 over 1/3, for example. So it's 2/9 over a third. Of course, you can put that into your calculator, but it is 2/9 multiplied by 3 over 1. So I'm getting 2/3 for my common ratio. So let's put that into our formula to give me Sn is equal to A, which is a third, times 1 minus 2/3 to the power of n over 1 minus 2/3, okay? And I have to leave it as n here because it didn't tell me how many terms it would like me to sum up. If it says find the total length of all the line segments removed after 20 steps, then I would sub in 20 for n. But it didn't. It said give your answer in terms of n, so I'm afraid n stays n. Okay, so that's equal to a third times 1 minus, there's not too much I can do with this, over, let's tidy the bottom, 1 minus 2/3 is a third. Okay, a third on the bottom cancels with the third on the top. So therefore for Sn, I am getting 1 minus 2/3 to the power of n. Okay, so that is the sum of the total length removed after n steps. Okay, and that was part 2, and there was 5 marks for that. Okay, part 3. Find the total length removed from the initial line segment after an infinite number of steps, and it's find the total length, okay? So this is that other formula, the sum to infinity one, which is down here, down the bottom, which is A over 1 minus R. Okay, it's still the same A because it's still the same sequence. It's still the same common difference, which is 2/3, and let's put it in. So it's a third over 1 minus 2/3. So it's a third over a third. So the sum to infinity is 1. In other words, what this means was if I had an infinite number of steps in this process and I kept chopping away bits of it, how much would I have chopped away? Okay, well, it's kind of easy enough to visualize this one. So that's why I like to use this one to explain the sum of infinity. You can see that this is your 1. So if you keep chopping away bits of it, you can see that you'll more or less chop away the whole line. Okay, so that's why the sum to infinity being equal to 1 for this particular one does actually make sense. Okay, so that's what sum to infinity means. And there was another 5 marks for that. Okay, so part B then asked you part 1. Complete the table below to identify the endpoints labelled in the diagram. Give your answer as fractions. Okay. Right, so if I go back here, I can see that I have point A, B, C, D, E, and F. Okay, and it's asking me what fractions are these. Okay, and remember in the Cantor set, the steps are you remove a third every time. Okay, so if this is 1/3, I hope you're okay that this is 2/3. Okay, you're counting up in a third, 1/3, 2/3, 3/3. So A is 2/3. B, okay. So like I explained when we were on part A, when there's a small fraction here, I like to have everything with a common denominator. So that's 1/9. If you write your 1/3 here at the end as 3/9, then it's not too hard to see that B then is 2/9. Okay, I hope that's okay. C, okay, so we're over this side now. So again, if you write the 1 out here is going to be 9/9. Okay, 2/3 is 6/9. So it must be 6, 7, 8, and 9/9. So I would say C is 7/9. D is 7/9. Is 8/9. Okay, E then. Okay, so you can see because I wrote in some of the common denominators, we have some of this work done. Let's see if we can figure out E. Okay, I'm just going to blot off a little bit because there's just too much numbers. Okay, so I have a third, which is 3/9. So this part here just before E is 2/9. Okay, now I need to write it as 27ths. So that's going to be 3/27. One, two, three. That's 3/27 there. It's going to be 6/27 here. So E is going to be 7/27. Okay. Let me just explain that again in case that was too fast. Okay. So there's 1/27. So that's going to be 2/27. He's going to be 3/27. Okay. So that makes sense. The 9th. Okay. Then if that's 3/27, then the gap in the middle is also going to be 3/27. So he's 6/27. So I make E out to be 7/27. Okay, and then of course he's 6, 7, 8, and 9. So up the end we have 1/3 being equal to 9/27. Okay, so in the same way then, I would argue that, where are we? F. So that's 9/27. He must be 18/27, the 2/3. Okay. All right, so F is up this end, and the 1 up here is 27/27. So if we count backwards from that, that's 26/27, 25/27, and of course he'd be 24. So I make him out to be 25/27. Okay, so not the easiest question at all. So I know I had 2/3, 2/9. I know he was 25/27. 7/9 and 8/9. And 7/27. Okay. And there was 10 marks for working out that particular table. Part 2 then, give a reason why 1/3 minus a ninth plus 1 over 27 minus 1 over 81 is a point in the Cantor set. Okay, if it's a point in the Cantor set, then it's an endpoint. Okay, because the only points that are in the Cantor set are these ones that's at the start and the end of all the little divides. Okay, so what point is that? Let me just grab my calculator. So I have 1/3 minus a ninth plus 1 over 27 minus 1 over 81. And I'm getting 20 over 81. Okay, so if I go back to my diagram, can you see now that I'm going to be on step 4 here? Okay, because step 4 is the 81s. Okay, so you're trying to figure out then, is 20 over 81 an endpoint? Okay, so I did it earlier, and how I did it was I literally just messed around with the points that are here and halving them and seeing which ones would end up being an endpoint in 21 or in 81. And to be honest, I had no fancy maths in doing it. I just did it by trial and error. Okay, and yes, it does end up being an endpoint. Okay, so there's a couple of ways of doing this. Yes, as it's an endpoint. Okay, and that's probably the easiest way of doing it, is just trial and error maths. Okay, and how did I do it? Well, I did it the same way as I figured out what F was, or D or E, or any of those points. So just basically converting these to 81s and just imagining them on the next line, and then you can figure out then if it's going to end up being an endpoint. Okay, and then the last one, the limit of the series 1/3 minus 1 over 9th plus 1 over 27 is a point in the Cantor set. Find this point. Okay, so the limit. Okay, and the dots. So all of them tell you you're going on to infinity. Okay, so again, a couple of ways of doing it. I just like the infinity formula. I find it the easiest way to do it. So A is 1/3. And what's my common difference? Okay, so let's work out our common difference. It's Tn plus 1 over Tn. So we'll go minus a ninth over 1/3. Of course, you could do it on your calculator or invert the bottom fraction and multiply. And you can see there that we're getting our common difference to be minus 1/3. So that's equal to 1/3 over 1 minus 1/3 is 1 plus 1/3, so it's 4 over 3. So again, invert the bottom one and multiply. So I'm getting the sum to infinity to be 1/4. Okay, and that was that question. That sum to infinity one was actually 10 points. So you can see we've only done 2 questions so far, but you can see how that, if it's a geometric sequence, how that sum to infinity comes up again and again. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.